Welcome to Pulsar's Career Point. This is a video on chemical properties of haloalkane or alkyl halides, covering the nucleophilic substitution reaction, the mechanism of SN1 and SN2 reaction. The student, let us know what do we mean by nucleophilic substitution reaction. What is a substitution reaction? The chemical reaction in which an atom or a group of atoms of the compound is substituted by another atom or group is known as substitution reaction. Now we have to know what is nucleophilic substitution reaction. The chemical reaction in which an atom or a group of atoms of a compound is substituted by a nucleophile is called a nucleophilic substitution reaction. It is represented as or designated as SN reaction. It is again of two types such as bimolecular nucleophilic substitution reaction or SN2 reaction and unimolecular nucleophilic substitution reaction or SN1 reaction. Let us come for bimolecular nucleophilic substitution reaction or SN2 reaction. What do we mean by bimolecular nucleophilic substitution reaction? When the rate of nucleophilic substitution reaction is dependent both upon the concentration of substrate and the nucleophile, the reaction is of second order and is represented as SN2. This is a single step reaction and is proceed through a transition state. Now, the rate of this reaction, nucleophilic substitution, bimolecular nucleophilic substitution depends on the concentration of both substrate and the nucleophile. Now, let us come for the example. When methyl bromide reacts with aqueous NaOH, then methyl alcohol and NaBr are formed. Let us come for the mechanism. First of all, NaOH in this aqueous state break down to give Na plus and OH minus. The nucleophile OH minus attacks the primary alkyl halide from the backside and forms a transition state where formation of new bond and breaking of old bond takes place simultaneously. And finally, the product molecule is formed with inversion of configuration as represented below. Now, what happens whenever the nucleophile OH minus attacks the methyl bromide from the backside? Then a transition state is formed where the breaking of old bond, that is CBr bond, and the making of new bond, that is COH bond, takes place simultaneously. This step is the slower step. Thus the rate depends upon the concentration of OH minus and CH3Br, and the transition state is formed. The transition state is unstable and very quickly, very fastly break down to give methyl alcohol with inversion of configuration. The methyl alcohol configuration is inversion, it is completely opposite to the methyl bromide. Thus, in this case, the mechanism occur here. How does OH minus attack from the backside? Then how the transition state is formed. Then we will get we can represent in the previous slide and also with this side also. And how the inversion of configuration is obtained, it is represented clearly in this video. Then Na plus Br minus combines to give NaBr. The nucleophile OH minus, after writing the mechanism, the description can also be written. Now, let us come for how this reaction depends upon the concentration of nucleophile OH minus and the substrate methyl bromide. Here the formation of the transition state by attacking of OH minus nucleophile to methyl bromide substrate is the slower step and is the rate determining step. So, rate is directly proportional to the concentration of methyl bromide and OH minus, that is the concentration of substrate in nucleophile, hence it is a SN2 reaction. The order of SN2 reaction is methyl halide greater than primary alkyl halide greater than secondary alkyl halide and greater than tertiary alkyl halide. Now let us come for unimolecular nucleophilic substitution reaction, that is SN1 reaction. What do we mean by SN1 reaction? When the rate of nucleophilic substitution reaction is dependent only upon the concentration of the substrate and is independent of the concentration of the nucleophile. The reaction is of first order and is represented as SN1. This is a two-step reaction and it is proceed through the formation of a reaction intermediate, that is carbocation. Here the rate is directly proportional to the concentration of substrate. Let us come for example. Tertiary butyl bromide reacts with aqueous NaOH to give us tertiary butyl alcohol and sodium bromide. First of all, the aqueous NaOH break down to give Na plus and OH minus. Here OH minus acts as the nucleophile. In the first step, the alkyl halide ionizes to give carbonium ion. This is the slower step and is the rate determining step. In this way, a tertiary carbocation is formed. As it is the slower step, it is the rate determining step, and the rate depends upon the concentration of tertiary butyl bromide. In the step 2, the tertiary carbocation is attacked from both sides by the nucleophile OH minus. It is very fast reaction. As a result, two products are obtained with retention and inversion of configuration. The mixture of retention and inversion of configuration is said to be the racemic mixture. The nucleophile can attack the planar carbonium ion from either side to give tertiary butyl alcohol with both retention and inversion of configuration, that is racemic mixture. And finally, Na plus Br minus combine to give NaBr. Here the first step is the slowest step and is the rate determining step. The rate is proportional to the concentration of the tertiary butyl bromide. Students, here the A should be replaced by the proportionality sign. Hence, the rate is directly proportional to the concentration of substrate. Hence, it is a SN1 reaction. The order of SN1 reaction is tertiary alkyl halide greater than secondary alkyl halide greater than primary alkyl halide greater than methyl halide. A student propulsor is with you at your every suggestion and comments. So don't forget to give your suggestion and comment in the comment box. Thanks for watching Propulsor's Career Point. Please like and share this video. Don't forget to subscribe my channel if you are watching it for the first time.